Hi, welcome to High School Maths. In our previous videos, we focused on how to change whole numbers from any base to base 10. Today we are focusing on how to change numbers of this form, numbers involving the fractional parts. Many a time, whenever students are posed with questions like this, they tend to get confused as to why this is being changed to a decimal because this is already in a decimal form. The answer is no. For the fact that there is a point here doesn't make this number a decimal number. For your information, decimals or decimal is a term that is used in only base 10 system. Yeah, so it is only in base 10 that you will hear the term decimals. And as you can see, this is in base 6. So we can't call this number a decimal. It is just a number involving a fractional parts. If this is the point, then to the left of the point contains the whole number parts, and from the point to the right. So how do we change this number into decimals that is in base 10? In our previous videos, we talked about how to deal with the whole number part, and we will follow the same pattern. We will follow the same steps. It's only getting to the end of the process that we will make slight changes in whatever thing. We will not even change. We will add something small to make this spicy. All right. Whenever you are posed with a question like this, we know that if this will confuse you, then you rewrite it in numeral form. So this is 3, 4, 1.25 base 6. The first thing we have to do is to identify the base in which this number is in. And we know it is in base 6. If it is in base 6, the second step is to take the base, multiply it by each of the digits in the numerals. So we will multiply each numerals with 6. So this is the same as having, the first one is 3. We multiply it by 6. We pick the second one, which is 4. We multiply it by 6. We pick the third one, which is 1. We multiply it by the base 6. We pick the fourth one after the point. We have 2 times 6. We have 2 times 6. And then lastly, we pick the 5. We multiply it by 6. All right. So after multiplying, we get the products here. So these are the products. If you multiply this and that, you get a product. Multiply that, you get a product. You get a product, you get a product, and you get a product. After this, the next step is to sum up the products. Summing up means adding the products. Adding the products. So we keep on adding. How do we add? We bring our plus signs. We bring our plus signs between them. After this step, we are now getting to the crucial part of this whole work. Now let's use this diagram. This diagram was meant for this stage. You see the point? That is it. Now, we are going to take the powers of the base. We are going to put powers onto the bases. So, moving to the right of this point, we will decrease the power by 1. And moving to the left, moving to the left of this point, we will increase the power by 1. So we decrease by 1 to the right and we increase by 1 to the left, starting with 0. So let's start with the left hand side, this part. Let's start. The left hand side ends at 1, so we are starting here. This is the left hand side, and this is the fractional part. That is it. So moving to the left, we will increase by 1, starting from 0. So we have 0 for the first one. We increase by 1. Plus 1 is We put it on that one. We increase by 1 again, and we are having 2. So this is 6 to the power 2. Let's go to the right hand side, that is to the right of the point. That one, we said from 0, we will not add, but we will subtract 1. We will decrease by 1. So 0 minus 1 is minus 1. So this is minus 1. We subtract 1 again, we are having minus 2. That is it. So we are done with the positioning of the exponents. We are done with the positioning of the exponents. We are done. Now, what's left with is just simplification. Let's move on with the simplification. We open the first bracket. We're having 3 times 6 to the power 2 means 6 times 6. That is 36. Plus 4 times 6 raised to the power 1 is 6. Plus 1 times 6 raised to the power 0. Any non-zero number raised to the power 0 is 1. So 6 to the power 0 is also 1. Plus 2 to the power 2 times. Now, according to indices, a to the power minus 1 is the same as having 1 over a. So we can rewrite this 6 to the power negative 1 as 1 over 6. Plus 5 times a to the power negative 2, according to this, is the same as 1 over a squared. So please take note. We can write 6 raised to the power negative 2 as 1 over 6 raised to the power 2. And 6 raised to the power 2 is 36. So we bring our 36. 36. Let me write it well. 36. All right. We move ahead. And then 36 times 3 times 36 is 108. Plus 4 times 6 is 24. Plus 1 times 1 is 1. Plus 2 times this is 2 over 6. And can be simplified as 1 over 3. Plus 5 times 1 over 36 is 5 over 36. Clearly, this forms the whole number part, and that forms the fractional part. So we can do it one after the other. So 108 plus 24 is 132 plus 1, which is 133. We are done with the whole number part. Now for the fractional part, you can use your calculator just to punch it and then have it there. Plus, but we will perform some simple arithmetics here. So we have 1 over 3 plus 5 over 36. According to fractions, we can add or subtract them only when their denominators are the same. So how do we make this 3 to become 36 so we can add them? So we multiply this one by 12 and that one too by 12. It's just the same as multiplying by 1. We are having 12 over 36 plus 5 over 36. Since we are having the same denominator, we can add their numerators. 12 plus 5 is 17. Now we are having 17 over 36. 17 over 36 approximately is 0.47 in 2 decimal places. Now adding the 2 is 133.47. Now this number is not accurately, it's not an accurate number, it is just an approximation because there are some other parts of the decimal part that we ignore. So we do not use equal to sign here, but we say it is approximately. It is approximately. So 1, we have 341.47 base 6 is approximately equal to 133.47 in base 10, and that's the same as having 133.47 without the 10, because any number without the base is assumed to be in base 10. Let's take a second example. And that one is 22.112 base 3. 22.112 base 3. So this is the 22 is the whole number part and 112 is the fractional part. We begin by identifying the base, which is 3. We multiply the base by each of the digits in the number. So 2 times 3, 2 times 3, 2 times 3 again, 2 times 3, 1 times 3, another 1 times 3, and lastly 2 times 3 again, 2 times 3. We want to find the sums, so we bring our plus signs. After that, we have to take the powers of the bases, the powers of the base. So we will have to put powers on it. Now, this contains the whole number part and this contains the fractional part. We know we increase whenever we are moving to the left from 0. So we start 0. We increase by 1, we have 1. And this is placed on the base. It's placed on the base. Now from 0 to the right, we decrease by 1. So we decrease by 1. We decrease by 1, which is 2. We decrease by 1 again, and we have a negative 3. Now we can simplify. Let me clean this so I can economize space. This is the same as 2 times 3 raised to the power 1 is 3, plus 2 times 3 raised to the power 0 is 1, plus, let me clean this so I can use the space, 1 times 1 over 3 plus 1 times 1 over 3 raised to the power 2 is 9, plus 1, is it 1? 2 times 1 over 27, that is 3 raised to the power 3. I should have used the space, but no problem. Let's come here. Now we can say that this time that is 6, plus 2 times 1, which is 2, plus 1 times 1 over 3 is 1 over 3, plus 1 over 9, plus 2 over 27. This is what we are having at this point. Let's clean this point since we have established what we want. Moving to the top here, we are having 6 plus 2, which is 8, plus 1 over 3 plus 9, 1 over 9, plus 1, is it 1, 2 over 27. That is it. Okay. We are done with the whole number part. We've been able to add. Now with the fractional part, let's use style to answer it. We want to add them. Now we have 1 over 3 plus 1 over 9 plus 2 over 27. We want all of them to have the same denominator. To make this denominator 27, we have to multiply both the top and down by 9. So multiplying by 9, we are having 9 over 27 plus, how do you make 9 27? You have to multiply by 3. So we do so for both the numerator and the denominator. So we have 3 over 9 times 3 is 27 plus 2 over 27. We can now add their numerator since the denominators are the same. Now 9 plus 3 is 12 plus 2, which is 14. We can now write that 8 plus the whole of that is 14 over 27. Good. I hope we can clean this now. 14 over 27 to, in decimal form, is approximately 0.5185. 0.5185. So adding the two, we are having 8.5185. This is an approximation because of this decimal part, so we can't use equal to sign. So in our final part, we say 22.112 base 6 is approximately equal to 8.5185 base 10. And you know we can ignore the 10 since it is base 10. And this is our final answer for that question. This is how we go about when you are converting numbers involving fractional parts to indifferent bases to base 10 or decimals. So it's as simple as that. You can rewatch this video to get everything clearer again. Now I can't leave you alone. I can't just leave you alone like that. I have to give you something to try. So let's try this. This is our third example. And it's one, we are changing 103.51 base 8. Yes, base 8 to decimals. So try it at home and leave your answer in the comment section. Kindly comment your observation as it will help us to improve upon whatever thing we are doing. But we are doing it with you. We are helping you and you are helping us. Alright, so thanks for watching. If you found this video very helpful, kindly subscribe, click the notification button so you'll be getting enough of these useful videos. Thank you once again. Bye bye.